Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. My contributions to mathematics is this. I discovered how to solve grand challenge problems known as the most computation-intensive problems arising in calculus and algebra. The parallel supercomputing solution of these grand challenge problems has large impact on humanity. I was 34 years old on the 4th of July 1989 when I discovered how to execute 47,303 floating point arithmetical operations per second per CPU that was not a member of an ensemble of 65,536 processors. I was in the news headlines as the African supercomputer genius that won top US prize and won it for discovering how to harness the world's slowest processors and use them to execute the world's fastest supercomputer calculations and also execute them while solving the toughest real-world initial boundary value problems arising in computational physics, abstract calculus, and extreme scale algebra. I totaled those calculations across my new internet. That was my new global network of 65,536 processors. I totaled those calculations on the 4th of July 1989 and did so to discover the world's fastest computation of 3.1 billion calculations per second. That ultra-fast calculation that I executed across that new internet made the news headlines because I unveiled the new parallel process solution to the grand challenge problems arising in STEM fields. To experimentally discover parallel supercomputing requires a mathematical maturity that includes knowing the partial differential equation and knowing it both forward and backward. The reason is that the partial differential equation, or rather its finite difference algebraic approximation, is the most recurring decimal inside the parallel supercomputer. Like the physical maturity needed to win a marathon race, the mathematical maturity needed to parallel process across a new internet must grow with experience. It took me 15 years, onward of June 20, 1974, of full-time study and research to master how to solve a system of partial differential equations and to deeply understand how to formulate it from first principles and on the blackboard, and how to solve that system across motherboards, and how to use my new parallel supercomputing knowledge to discover and recover otherwise elusive crude oil and natural gas that were buried millions of years ago and buried 1 mile deep in an oil field that is the size of a town, such as those in the Niger Delta region of Nigeria, that is my country of birth. In 1989, I was in the news because I experimentally discovered how to parallel process across a new internet. That's a new global network of 65,536 tightly coupled central processing units that shared nothing between each other. As a 10-year-old walking to school along Bonoba Street, Abo, Nigeria, I could not explain why I had to learn the quadratic equation, nor did I understand how the quadratic equation will help solve the economic problems of Nigeria. To us students at St. John's Primary School, Abo, Nigeria, solving the quadratic equation was merely mental gymnastics that had no real-life application. To us students, it seemed like the quadratic equation was invented to mentally torture us. Fast forward 25 years, from 1964, from Abo, Nigeria, to Los Alamos, New Mexico, United States, I became the subject of school inventor reports in the US, and was so because my experimental discovery of practical parallel supercomputing was the new knowledge that was not in computer science textbooks that led to the development of new supercomputers that can be up to 1 billion times faster than old supercomputers. I am studied in American schools for my contribution to the development of the computer. I am the subject of school reports on inventors, in part because the quadratic equation of algebra increased my mathematical maturity. That maturity was a prerequisite to solving the once impossible to solve partial differential equations and to parallel supercomputing the solution of the companion large-scale algebraic equations that must be solved prior to discovering and recovering otherwise elusive crude oil and natural gas. Back in the early 1980s, I was a supercomputing rebel who was programming massively parallel supercomputers and doing so in the unorthodox and counterintuitive message passing way. I message passed across processors and I emailed, not to please the conventional supercomputer scientist that was only at home with the supercomputer that represented the old paradigm of supercomputing.
Insightful and brilliant lecture.